The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Welcome back to Element 14 Presents. My name is DJ, and today we're going to finish my journey of building an animatronic Claptrap case mod from scratch.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
In part 1, we went over the 3D model that I made of Claptrap and my design goals. Well, in the past few weeks, I've been pretty busy 3D printing, CNC machining, fabricating random parts, and painting. So much painting. And now it's time to actually put Claptrap together. And we're going to talk a lot more tech so I can explain how I'm actually going to make him animatronic. By the way, did I mention that there are a lot of parts to this build? Because there are a lot of parts. Despite his simple appearance, Claptrap is a fairly intricate robot, and there are over 100 3D printed pieces and 45 machined parts that I made for this build. Not to mention all of the miscellaneous hardware and other bits of metal and plastic that keep it together. This is gonna take a while to put together, but I've got a plan. Feature number 1 is sound. I want Claptrap to be able to speak voice lines from the game. So in order to do that, I probably need a speaker, and I probably need an amplifier for that speaker, and then I probably need a sound source for that amplifier. Easy enough. So for my audio solution, I am going to be using the Speaker Fat, which is currently my favorite little all-in-one audio board because it has an 8-ohm 2-watt speaker, an I2S DAC, and an amplifier. So it's super convenient to use. Now, this could be used with a microcontroller, but it is built for the Raspberry Pi. So I am going to be using a Raspberry Pi 3 Model A just because it's compact and easy to use. And I don't need the horsepower of a Raspberry Pi 4. And this is overkill for just playing back audio effects, but I like the functionality and the ability to expand the feature set of my projects. So this will be a little bit more versatile than just using a microcontroller. If I'm going to make Claptrap's eye pan and tilt, the easiest way to do that is with some standard servos. Now, I could directly drive the signal line of the servos with the Raspberry Pi. 3.3 volts is out of spec, but usually it does work. Although in this case, I am going to be using a separate pulse width modulation driver board, which will just make things a little bit easier and tidier in terms of wiring. Last but not least, I want Claptrap to be interactive, and one of the most fun ways to do that is with speech recognition. So the Raspberry Pi is certainly capable of running offline speech recognition, but I don't have a USB microphone, and I do have this speech recognition module that I've had for years, and I just want to use it up in a project. So I think I'm going to go with this little clipboard that is a really nifty way to integrate speech recognition into your projects. I'm not going to go into super detail of how the speech recognition module works. You can, of course, always find more information by clicking the link to the project in the description. So I'm just going to go ahead and power it on. And suffice it to say, one of the things you can do is control the GPIO based on voice recognition commands. So I've already gone ahead and programmed some pre-recorded things. And I've connected one of the GPIO to my little Klein multimeter. All right, so, hey Claptrap. There we go. Stop. All right. That looks good to me. So I've got some more things programmed in there, but you get the gist. So I do need to power the darn thing, and conveniently enough, Newark sells exactly one full-size ATX power supply, this 1000 watt Cooler Master model. And it's certainly overkill for my rig, but it was available. Now this could power the Raspberry Pi and the servos, but I don't want to mess with that noise. Literally. Motors are noisy, these are cheap servo motors, and I don't want any electrical connection between these motors and my motherboard. I had considered using something like this isolating DC-DC converter, But still, I'm really paranoid about this, and I don't want to lose $1,000 worth of hardware because of a $10 motor. So I'm just going to completely separate the Raspberry Pi motors, and they'll have their own 5-volt, 3-amp brick, and that will connect to a power jack and have a separate power switch so that there is minimal chance. I mean, if they catch fire, that's another story, but that'll never happen, right? All right, so let's talk about Claptrap's chassis. There are a few key things that give him his structure and that inform the rest of the design. So most of the components mount to these two plywood plates. There's a top plate and a bottom plate. And at the corner of the plates, you'll find one of these blocks. And each of these blocks has pegs for these aluminum tubes because this seemed to be the most sensible way to give him his core structure. He's actually some really strange angles, and none of his body panels are at right angles to each other. So that just made the most sense, and it also required the least amount of 3D printing. So most of the strength comes from the plywood and aluminum. Now you'll notice there's a cutout at the bottom too, and that's because the full-size ATX power supply is just a little bit too big, but it does recess into there, and it does fit nicely. You can't see it from the front, but it's one of those things where I could have made him bigger, but it would have made his design more expensive and just a lot more of a pain to put together. So that's gonna stay as it is. Now there's one more key panel, and that is the motherboard plate, to which of course my ATX motherboard will mount. Click. Okay, so let's talk about Claptrap's eye mechanism. So as you can see, the assembly consists of a few key things. We've got the main support bracket, and this will attach to his core frame. We've got this supporting ball joint, which the eye rests on, and we've got two control ball joints. So these respectively change his pan and tilt. So there are there's one servo per axis, and there's one little hole for the white LED for his lens that I'll install later. But I've gone ahead and plugged it to a servo tester. It's just a quick way to test if your servos are working, of course. And let me go ahead and plug it in, and we should get some motion out of this. So I have to support it via the support bracket. Imagine that. So let me just... So here's the tilt servo. The range of motion isn't extreme, but it is enough for what I'm looking for. All right, so we've got tilt, and let's plug in the other one. Ugh. Let's make sure we get the wires right. All right, hold it by the support bracket, and that's pretty good. I'm pretty happy with that. All right, so motors are good. The mechanism doesn't bind up. This is the first time I've ever used 3D printed ball joints, and I did lube them up a little bit, but I'm really surprised at how nicely they work. I'm definitely gonna use more ball joints in my projects just because it's a really fun thing to print. But this is good to go, so I'm going to install this in his body now.
So before I package him up, and you can't really see inside all that much, I will talk about the internals. As you can see, this is what you might call a tight fit. So everything is modeled and where it's supposed to be, but you know, there's really only 1 millimeter of clearance in some areas, just because it's a tight design. And up here I've got the 140 millimeter exhaust fan. Of course, my motherboard, GPU, which I know doesn't quite have enough of a gap between the power supply for ideal airflow. I can just monitor the temps, and if things aren't okay, I can always just turn off my computer and figure it out later. We've got a back panel, so just the mount for the GPU, the jack for the separate 5-volt power supply for the Pi and servos, the main power button, and then this is the power switch for the Pi and servos. So the power LED for the computer actually will be in the tip of, well, it is in the tip of his antenna. I can't get up there. Yeah, there's an LED up there. I'll show it later when it's turned on. It's just an LED. But we are just about ready to package this guy up and test him out. All right, say hello to my new friend slash gaming computer. Oh boy, this has been a long month of my life. This is easily the most complicated thing I've ever worked on, and he's still not done. So you might notice that Claptrap is different as to how he appears in the games. This is not a replica of any one particular Claptrap. As I noted earlier, I sort of mixed and matched from various models throughout the series. And one major difference is that he's brand new. He's brand spanking new. As far as I'm aware, Claptrap has never appeared this fresh. He's pretty banged up when you meet him in Borderlands 1, and he's really only gotten worse as the series goes on. But I would like to weather him eventually. That's just going to be a lot more work to make him as accurately beat up as he is in the game. And one other detail that I want to add, but I just didn't have time for, are his characteristic pinstripes that run across his head and down to the middle of his face. That just wasn't absolutely critical for his design, but all the other key features are there. His ear flaps actually do slide in and out. His arms are posable somewhat. The fingers, not as much. These joints are really tight, but that's okay. One other detail that I didn't really acknowledge is the fact that he's on a stand, and I'm using 2 identical monitor stands that I got surplus for a few bucks. It's really temporary. I mostly just wanted to be able to freely spin his wheel. but they're spring-loaded, so he's actually slipping. You could see him slip in the earlier clips. And he's a little tilted, which I'm actually okay with. He's always generally tilted in the games. But let's go ahead and activate the animatronic aspects of him and see what else he can do.
Oh, but before we begin, do you guys remember that voice recognition module? Well, it may have given up the ghost, or at least something about it isn't quite working as expected. It is a few years old, so we're going to do this the manual way with a good old mouse and keyboard.
So I've got my wireless keyboard here, and here's how I'm going to control Claptrap. Of course, the program is running on the Pi itself. Now I've mapped the pan and tilt functionality to the WS and D keys, so it's actually pretty responsive. I'm toggling fairly quickly, which I'm surprised at how quickly the servos are responding. They don't have infinite acceleration, but they're still pretty good, and I'm happy with that. I'm happy with that responsiveness. I think Claptrap is happy too. So let's go ahead and test out his voice functionality, shall we?
I am alive!
Claptrap, do you have any words of wisdom for the audience?
I got nothing.
By the way, he is also a gaming PC, so maybe I should reach inside him and turn him on. Claptrap, are you ready for that? I'm sorry, I can't resist this joke. It's too good and too easy. All right, so I don't exactly know how to frame this shot. I definitely want Claptrap up there, and I want the game running in the background, but I can go play Borderlands 3 on my gaming PC, which is Claptrap. I don't think it gets better than that. I hope you guys enjoyed this build and connect with me on the Element 14 community. You can find the link in the description below, and I will see you guys next time. Thanks for watching.
Hey Claptrap, do you have any parting words for our audience?
Hey, want to hear the new dubstep song I wrote?
Alright, I think that's quite enough.